In this video, we will discuss about the condition for the bright and dark fringe in a diffraction pattern. For that, let me consider a slit like this. A slit, this is the slit. A slit basically means an opening. And let me place a source as on the left of the slit, a source emitting monochromatic light, which means a light of single color. And in order to focus the light onto the slit, let me consider a convex lens L1. We'll get three rays. One passes undeviated and we'll get two parallel rays. Let me consider three rays, okay? These three rays will reach the slit. Okay. Let me mark these 3 points as some. Let this point be some A, this point be some C, and this point be some some B. So we know the width of the slit. This is the width of the slit AB, and let its width be some A. Okay. Let me consider this point C as the exact midpoint of AB. When I join these 3 points like this, this line is actually perpendicular to the path of the ray. So that will make this line AB a wavefront. Okay. This is the direction. Okay, and according to Huygens principle, Huygens principle or Huygens principle, we usually call him as Huygens, whatever. According to his principle, every point on this wavefront acts as a source of secondary wavelets. Before that, let me consider a screen in here. Okay, at some distance, let's say D from the slit. Okay. So definitely three rays from the point. Let me mark this point as P. Definitely these 3 points will emit rays and they will reach the point P. And they have a path difference because the ray from A will have to cover more distance to reach the point P. So there is definitely a path difference between the rays from the point B and A. Let me consider these 3 rays. Before that, let me consider another convex lens in order to focus the diffraction pattern onto the point P, L2. So a ray from the point B will move like this and it will reach the point P. Another ray from the C also will reach the point P like this, and let me take this ray passes through the optic center so that it will move undeviated. You can take any ray, okay? That's not the point. We need to find the path difference between these 3 rays. That's the main thing in here. So clearly there is a path difference between the rays from, that is ray BP and AP. In order to find the path difference, let me draw a perpendicular from the point B, perpendicular to these 3 rays, perpendicular to the direction of these 3 rays, so that this will be 90. Okay, so the path difference between BP and AP is this length. Let me mark that as AE. AE. So the path difference in here is actually AE. Now let me see, this angle is actually theta. Let me draw that triangle again. This is the triangle. This is our B. This point is A, this one is E. I just drawn this triangle BAE. This one is 90. I took this angle as theta. Okay, and we know this length is actually A units. That's the width of the slit. Okay. Now, if we need to find an expression for the path difference AE. So let me consider sine theta. Sine theta is equal to opposite side, that is AE, divided by hypotenuse. Hypotenuse is just opposite that of 90 degree. So this is the hypotenuse. AE by AB. That is sine theta is equal to AE divided by AB. We know that as A. AB is actually A. So we have the path difference AE is equal to, taking this A to the left, that will be A sine theta. A sine theta. Let me call that as equation number 1. So we need to find a relationship between this path difference and which kind of fringe is formed at the point P, whether it is dark fringe or bright fringe. Now suppose if I take AE is equal to some lambda, that is the wavelength, 1 times the wavelength of the light, or you can rewrite the equation as A sine theta is equal to AE. I just took that as lambda. I just want to check in this condition whether a bright fringe or dark fringe is formed at the point P. For that, let me break this slit into 2. Actually, we have C as the midpoint. So we have 2 half slits, or I just broke the slit into 2, that is BC and CA. And I took a point, let's say some B1 in here, and at a distance of A by 2, I took a point C1 in here. That means this length B1, C1 is A by 2. This length is A by 2, B1, C1. This whole length is A. Let me draw that again in here. Before that, if I draw parallels to AE and BE, I'll get a triangle. This one is 90. If this is theta, since this is parallel to this one, this also is theta. So we have another triangle. B1, C1. This one is theta. This length is A by 2. Okay. This B1, C1 is A by 2. Let me take this point as some E1. And if I take sine theta in here, sine theta is equal to opposite side C1 E1 divided by B1 C1. So C1 E1 will be B1 C1 times sine theta. What does this C1 E1 actually mean? C1 E1 is this one. Is the path difference of the points B1 and C1. That is, if I take a point B1 in here, like we did in here, C1, this point C1, this point C1, the path difference of the light reaching these points, reaching the point P, is the path difference is the C1. Okay, path difference between the rays from the points B1 and C1 is actually C1 E1. And we know B1 C1 is A by 2 sine theta. We can write this as A sine theta divided by 2. And we know A sine theta is actually lambda. So that's equal to lambda by 2. So what does this actually mean? That means if the path difference is half of lambda by 2, that is a fraction of wavelength, the fringe formed in here will be the dark fringe. That means a ray from the B is cancelled by the corresponding ray from the point C. Similarly, if I take any points on the slit, on the first half of the slit, it will be cancelled by the corresponding point on the other half of the slit. See, let me draw that again to make it more clear. See, this is our whole slit BA, and I have divided this whole slit with the point C. That is, we have BC as a first slit and CA as the second slit. Okay, so this is BC and this one is CA. So this is the first slit and this is the second slit. So every point from the B is cancelled by a corresponding point in the second slit. Okay, this is cancelled by this one. Similarly, all the points in the first slit is cancelled by a corresponding point in the second slit. So when this condition, so the initial condition is this one. So when this condition persists, we get a dark fringe in here. Okay, so the condition for the dark fringe is A sin theta is equal to lambda. And we can prove that when it is a multiple of lambda, that is A sin theta is equal to an integral multiple of lambda, that is n lambda. The condition, this is the condition for dark fringe. Clear? Now what happens? Again, let me take this triangle. That is this triangle BAE. When I take the sin theta is actually AE divided by this AB. Implies sin theta is equal to AE divided by, we know, AB is A. So AE is equal to A sin theta. Now what happens if AE is some 3 lambda by 2 or 3 by 2 lambda? That means A sin theta is equal to 3 by 2 lambda. Okay. Now let me break this triangle into 3. Listen this part very carefully. Let me draw this triangle again. That is this triangle B, this one is B, A, E. Now let me divide this into 3 equal parts. So that this whole length is actually A, that is BA is A, and this length is actually A by 3. And if I take a point in here, let's name that as B1, and another point in here, let's take that as C1, so that this length is actually A by 3. And I can draw parallel to these two lines and I'll get another triangle. Let me call that as BE1. If this is theta, this also is theta. Okay, let me take that triangle. Let me zoom this triangle B1, C1 and E1. This one is theta and this is A by 3. And we know sin theta is equal to, let me write it here, sin theta is equal to C1 E1 divided by this length B1 C1, that is actually, let me write B1 C1 itself. So this is equal to C1 E1 divided by A by 3. When you take this to the left, you will get C1 E1 is equal to A by 3 sin theta. This can be written as a sine theta divided by 3. That is equal to, we took a sine theta as 3 by 2 lambda. So 3 lambda by 2 divided by 3. So this 3 and 3 will get cancelled. That will be lambda by 2. So we have C1 E1 is equal to lambda by 2. And what actually that means? See, all the points from B1, all the points from the 1/3 of the slit, that is from this one, will be cancelled by the points from the slits from the second third of the slit. That is, if I take a point B1 in here, that will be cancelled by a point C1. If I take another point on the first 1/3 of the slit, it will be cancelled by the 1/3 of the second slit. Okay, that is from a point in here. Clearly, these two slits, that means if I broke this whole slit into 3, all the points from the slit 1, see this is first, will be cancelled by all the corresponding points from the second slit. So this will be eliminated by this one. And the remaining 1/3 still, this is also a by 3. And there will be rays from the remaining third of the slit. See, actually we have 3 slits. This one is completely cancelled by this one. But this one still remains. So the rays from this third will move to the point P and produce a constructive interference at point P. So what's the initial condition for that to happen? It's actually this one, a sine theta equal to 3 by 2 lambda, or generally you can write a sine theta is equal to 2n plus 1 lambda by 2. To get 3, we have n equal to 1. When n equal to 1, it is 3 lambda by 2. When n equal to 2, 3, etc., this is the general case. So this is the condition for the bright fringe. Okay.